Time travel.
Time travel, but not the Hollywood kind.
Right.
The kind that has actual scientists debating whether it's even possible.
Yeah,
We've got 3 new papers
it's really interesting.
to dig into, and they are tackling some really big questions.
How time travel has gone from, like, purely science fiction to something that researchers are actually seriously considering.
Yeah, and I mean, one of these papers is all about this idea of emergent space-time.
Yeah.
What is that?
So imagine space-time,
Okay.
which is like the fabric of our universe, right? Imagine it's not this rigid thing,
Okay.
but something that kind of emerges from something deeper almost. Like if you imagine a tapestry that's woven from quantum threads.
Okay, I can kind of see that, but
Yeah.
why does that matter for time travel?
So that could mean that the classic rules about time travel that we think we know, the ones based on Einstein's theories,
Right.
might not completely apply. Like if space-time is emergent, then it's like the rules of the game change when you realize that the game board itself is constantly in flux.
So those like impossible paradoxes.
Exactly.
Like going back in time and accidentally preventing yourself from being born.
Exactly.
Maybe they aren't actually set in stone.
Yeah, if space-time is constantly kind of emerging from this quantum realm, who knows what kind of weirdness is possible.
Right.
And we even have things like causal set theory, where space-time is thought to be made up of these tiny fundamental units like pixels of time.
Hold on. So instead of time flowing smoothly, it's more like a series of snapshots.
Yeah.
That's,
Hard to wrap my head around.
it's definitely mind-bending.
Yeah.
But it's one way that physicists are trying to reconcile general relativity with quantum mechanics, and it can have huge implications for how we think about time travel.
So we've got this emergent space-time thing, which is pretty wild. But
Yep.
let's get a little more down to earth. Does any of this research actually say time travel is possible? Actually, yeah. One of the other papers describes a specific type of space-time where time travel is mathematically possible.
Okay.
And get this.
Yeah.
It doesn't require any crazy black holes or wormholes.
Really?
Yeah. It's called Norton's model,
Yeah.
and it involves something called a conical singularity.
That sounds complicated.
I know it sounds a little complicated, but
Yeah.
think of it like a fold in a piece of paper where time can loop around.
Right.
Around this fold, time gets all twisty, and observers following certain paths could actually encounter their past selves.
So I could bump into myself from yesterday.
Potentially, yeah. Though in this model, your past self would be aging in reverse.
Okay.
The space-time is what we call non-time orientable, meaning time doesn't flow in a single direction.
Wow.
Like imagine a clock running backwards as you travel along certain paths.
Wait, time running backwards. This is getting weirder and weirder.
It is, and it's really interesting because it challenges the typical way we think about time travel. You know, we're so used to those Hollywood tropes where you jump in a time machine and everything basically looks the same.
Right.
But in this model, the very nature of time is warped.
Yeah.
It really makes you question everything you thought you knew about time.
Okay, so we've got space-time that's potentially emerging from this quantum soup, and a model where time can twist around itself.
Yeah.
Are you seeing any connections between these, like, out-there ideas?
Yeah.
They do seem like they're pushing the boundaries of physics and maybe sanity a little bit, but
Yeah.
there's one big thing we haven't talked about yet.
Oh.
Paradoxes.
Paradoxes, yeah. The classic time travel dilemma.
Right. What happens if you go back in time and you accidentally prevent your own birth?
Right.
Wouldn't that just create a massive contradiction?
Yeah.
Like it's the whole grandfather paradox thing?
It's a question that's plagued time travel enthusiasts for ages.
Right.
But one of these papers actually offers a pretty mind-blowing solution.
Right.
Entangled timelines.
Entangled timelines. Like entanglement, like that spooky action at a distance stuff from quantum mechanics.
Exactly. This paper proposes that every time you travel to the past, you don't actually change the original timeline.
Okay.
You create a new one, which is entangled with the first.
Okay.
So if you went back and, say, saved your grandfather from a car accident, you wouldn't erase yourself from existence.
Right.
You'd simply create a new, slightly different timeline where that accident never happened.
So it's less like I'm rewriting history and more like I'm creating a whole new copy,
Yeah.
like branching universes.
That's a great way to visualize it.
Okay.
And because these timelines are entangled, they're not completely independent. They're connected in a way that prevents those pesky paradoxes from popping up.
So no matter what I do in the past,
Right.
I'm not going to accidentally erase myself.
Right.
I'm just creating a new reality
Yeah.
that's both terrifying and kind of awesome.
It certainly challenges our assumptions about cause and effect. And it gets even wilder when you connect this idea to the many worlds interpretation of quantum mechanics.
Oh, boy.
That theory suggests that every quantum measurement causes the universe to split,
Right.
creating multiple universes where every possible outcome exists.
I've heard of that, but to be honest, it always seemed a little far-fetched.
I hear you. It's a lot to take in.
Yeah.
But this paper is basically applying that same logic to time travel, suggesting that each trip to the past creates a new branch of reality.
So somewhere out there, there's a version of me who went back in time and became a famous astronaut, or one that stayed up late studying and aced that physics exam I bombed.
Okay. Or a version of you that made a completely different choice at a crucial moment, leading to a totally different life path.
Yeah.
It really makes you think about all the possibilities.
Okay, my brain is officially fried.
Yeah.
Emergent spacetime, twisty time, and now infinite realities.
Yeah.
Time travel is a lot more complicated than I ever imagined.
It certainly challenges our understanding of the universe. But the amazing thing is that these aren't just crazy ideas cooked up by science fiction writers.
Right.
They're coming from real scientific research pushing the boundaries of what we thought was possible.
So we're not just debating whether time travel is possible anymore.
Right.
We're actually trying to figure out how it might work on a fundamental level.
Right.
That's pretty incredible.
It is, and for you, listener, this means that the next time you watch a time travel movie,
Yeah.
you can appreciate it on a whole new level.
Right.
Think about the concepts we've discussed today. Emergent spacetime, non-time orientable spacetimes, entangled timelines.
Yeah.
The science behind time travel is becoming as mind-bending as the fiction.
Yeah, it's like those movies are suddenly a lot more thought-provoking.
Right.
But with all this talk about the possibilities, what are the biggest takeaways for our listener? Time travel might be possible, it could mess with cause and effect, and it might lead to a whole bunch of alternate realities. Did I miss anything?
I think he hit the nail on the head. What's so exciting is that time travel isn't just a fun thought experiment anymore.
Right.
It's a topic that's pushing the very boundaries of physics, forcing us to reconsider our understanding of time, space, and reality itself.
It's definitely a lot to ponder. And honestly, after all that, I think we could all use a break. All right, I'm back. I think my brain has finally rebooted after all that mind-bending time travel talk.
Yeah, it's definitely some pretty wild concepts.
We've been through the ringer today. We've got emergent space-time, where the fabric of reality could be a lot more flexible than we thought. We've got models where time can twist and turn, even run backwards. And then we've got the possibility of entangled timelines, where every little choice could spawn a whole new reality.
I know, it's really...
Yeah.
it really makes you think.
But here's what really gets me. This isn't just science fiction anymore.
Right.
Physicists are taking these ideas seriously.
Yeah.
They're trying to figure out how time travel could actually work.
That's what I find so fascinating is we're not just asking if, we're asking how.
Right.
We're starting to see what the mechanisms behind it could be.
Yeah.
The rules that might govern time travel.
Right.
If it does indeed exist.
It's like we're putting together this massive cosmic puzzle.
Yeah.
And time travel is this missing piece. That could completely change how the whole picture looks.
Exactly.
So for everyone listening, what's the big takeaway? Besides maybe having a bit of a headache right now?
I think the biggest takeaway is this. Time travel isn't just fantasy anymore.
Right.
It's a real area of scientific research. People from all different fields are working on it. Physics, math, even philosophy.
It really brings everyone together.
It's a truly interdisciplinary field, and that's what I find so exciting about it.
Me too.
It forces us to think outside the box, to challenge what we think we know about time and space and reality itself.
And who knows, maybe one day, these theoretical models we've been talking about could become blueprints for building real time travel technology.
Exactly.
I mean, just imagine our descendants hopping back and forth through time.
I know. It's
visiting different eras, maybe meeting alternate versions of themselves.
really a mind-blowing thought.
It is. That's something for everyone to think about. What would that world look like if we could travel through time?
Yeah. How would it change how we see history or our place in the universe?
So many big questions. And on that note, that is all the time we have for today. Thanks for joining us on this deep dive into time travel. It's been a wild ride.
It has.
Until next time, keep those imaginations going.